सर
हम्म,
मानसी का मैथ्स का ट्यूशन है, वो शायद खत्म होने वाला है कुछ नहीं।
it is going to end. Okay. So how are you guys? Krishna,
Good evening, sir.
good evening. How are you? Fine.
Yes, I'm fine.
Okay. So did you get the assignment?
Yes, sir. I got it last week, sir, but I was not able to do that.
अच्छा, कल का नहीं मिला कुछ?
Sir, I got 2 assignments last week. Just 1 second. I'll just check.
अच्छा, अच्छा. So again you will be getting 2 today also. ठीक है. What about you, Hamza? हिबा कहाँ है Hamza? Yes, Hamza.
No, sir, not
Hello.
uploaded yet. The assignment
Not
is
uploaded.
not.
Okay. Yes, Hamza, hello. Am I audible?
Yes, sir. Yes. Sir,
अच्छा,
she's
he's
joining.
joining. Assalamu alaikum, Hiba. How are you? Yes, Hiba. Am I audible?
Yes, sir. I'm fine, sir. How are you?
Fine. I'm good. I'm good. अभी आपके स्कूल में क्या चल रहा है वैसे हमजा?
Sir, solutions.
सोल्यूशन नहीं चल रहा है. ओके. कहाँ तक पहुंचा सोल्यूशन?
Sir, when I was doing the test yesterday, I saw a few similar questions to the last class we have done. So, like we
आज
have done
स्कूल
the
में
yes, we have started with the basics and basics of that lesson.
अच्छा स्टार्ट हुआ है अभी सोल्यूशन चैप्टर?
Yes, sir.
अच्छा अच्छा अच्छा. तो इससे पहले क्या करा रहे थे वो हल की हल वगैरह क्या?
No, sir. Before that, the first chapter was
सॉलिड स्टेट
forgot
करा रहे थे?
yeah, the solid state. Yeah.
I forgot the name only. Okay. So today last class में हम लोगों ने जहां तक किया था ना, so we did one question on Henry's law. Okay, and yeah, next was about application of Henry's law. अक्षय और दोनों ही अक्षय एंड मानसी दोनों का मैथ्स क्लास होगा. अक्षय तो ज्वाइन कर लिए हैं, मानसी खैर. एप्लीकेशन ऑफ. गुड इवनिंग. हाउ आर यू अक्षय?
Fine, sir. Sorry.
No, not a problem. I know that you have a maths class, na?
Yes, sir.
अच्छा. Okay, चलिए खैर. Applications of Henry's law. Should I stop for 2-3 minutes? हाँ, अक्षय, it's fine. मैनेज कर लेंगे आप.
What, sir?
Do you want me to wait for a few minutes?
For what, sir?
अरे अभी आपका मैथ्स क्लास खत्म हुआ है, सीधा आप
Yes,
केमिस्ट्री में आ गए.
No problem, sir. No problem.
No problem. Okay.
Yes, sir.
Fine. How are you, Mansi?
I'm fine, sir.
Fine. अभी खत्म हुआ क्लास?
Yes, sir.
Okay. So applications of Henry's law. ठीक है. So just to remind you guys, what does Henry's law say? Henry's law says that if I increase the pressure, then the solubility of a gas in liquid will also increase. If I increase the pressure, then the solubility of gas inside the liquid will also increase. Okay. Now, if you remember properly, if you remember something, all of you have, you must have drank Pepsi, right? You don't get Pepsi in Saudi. I think
No,
you
sir,
all
we
get
get.
you get Pepsi.
No,
है
sir,
ना?
that's for Saudi only.
Sorry.
Sir, it is written Pepsi in Arabic, right?
Do you know why it is written in Pepsi in Arabic?
So there is no the letter P in Arabic, so.
There is no sound as P in Arabic. Correct. So when you have Pepsi, and if you open it, so you see that it is like काफी pressure रहता है bottle के अंदर. Yes or no? It is sealed pack at a very high pressure. Correct?
Yes, sir.
Right. What about others? बाकी लोगों ने नहीं पिया है. अक्षय, मानसी, कुलसुम, हमजा, यूसुफ, आतिफ.
Yes, sir.
The bottle is sealed pack at a very high pressure, right? Why is that? Why it is sealed pack at a very high pressure? It is sealed pack at a very high pressure to increase the solubility of CO2. We have CO2 in that, na? अच्छा, अब यही याद कीजिए. You must have also drank Maaza, Slice, and these very fruity drinks, right? Yes or no?
Yes, sir.
Yes, sir.
But they are not sealed pack at a very high pressure. Correct है ना?
Yes,
What
sir.
are sealed pack? So those soft drinks or those sodas which have CO2 in it, they are sealed pack under a very high pressure because to increase the, please write this with me, to increase the solubility of CO2 in soft drinks and soda water. CO2 in soft drinks and soda water. The bottles are sealed under high pressure. They are sealed under high pressure. This is the first application of Henry's law. Okay, the number one application of Henry's law. Please write this down. For the second and third, we have to understand about atmospheric pressure palette. Okay, we have to understand something about atmospheric pressure. Write this down. To increase the solubility of CO2 in soft drinks and soda water, the bottles are sealed under high pressure. चले आगे बढ़े? Yes or no? Tell me.
Yes, sir.
Okay, fine. Now, so this is C. You don't need to draw it, okay? Draw mat kijiyega. This is C. Then you have mountains. Okay. So I think like near the Jordan border, Jordan Saudi ka jo border, there you have this kind of arrangement, right? You have sea and then there is a road and then you have also some mountains. कोई गया उधर जॉर्डन की तरफ? हम तो गए नहीं, हम तो सिर्फ ब्लॉग्स देख के बात कर रहे हैं, but still you can see that we have 3 points. I will talk about this first point, that is the sea level. Okay, second. Second point is high altitude वाले को up here. Let us say in this point, this is the second point, that is in high altitude. It's very high altitude. Third is deep sea, deep inside the sea. Okay. So you have to tell me, where will you experience lowest pressure?
High altitude.
Krishna, is that you?
No, sir. Sir, I think it's sea level.
Sea level. Okay. Who said high altitude? Yusuf or Atif? Atif, I think. अक्षय, किसने कहा था? अरे हाँ, तो बता तो दीजिए.
Yes,
अक्षय. अक्षय. Okay, fine. So how many, मतलब like अभी तक 2 ऑप्शन मिले हैं हमें. I have got sea level from Krishna. I have got high altitude from Akshay. So tell me first of all, raise your hand if you are with Krishna. सी लेवल वाले?
Yes, sir, I changed my mind, sir. It's high altitude.
हाई ऑल्टीट्यूड, ओके। हाई ऑल्टीट्यूड के लिए रेज योर हैंड, और जो भी हैंड रेज करेगा उससे हम एक्सप्लेनेशन पूछेंगे फिर। अक्षय ने तो कहा है हाई ऑल्टीट्यूड, हाई ऑल्टीट्यूड ना, ठीक है। हमजा बताइए, व्हाई हाई ऑल्टीट्यूड विल हैव लोएस्ट प्रेशर? हमजा, हमजा, कैन यू हियर मी?
Yes, sir. Yes. So
हाँ
thinking
बताइए,
for an
व्हाई?
explanation.
सॉरी,
So thinking for an explanation.
थिंकिंग नाउ यू आर थिंकिंग फॉर एन एक्सप्लेनेशन। हाथ रेस करने के बाद भेड़ चाल चल दिए हैं, उसके बाद फिर सोच रहे हैं कि हम क्यों चल रहे हैं ऐसे?
No, sir. No, no. Because like I knew that it would be like that, but I'm not sure about the reason.
हाँ, you're not sure about the reason. If it is not if there is no explanation, that is not science. ठीक है, ये तो like you are just you have read something from the book and you remember it, है ना? या तो कभी किसी ने पढ़ाया होगा और आपको बस ये चीज याद है। अच्छा, अक्षय आप बता सकते हैं, आप ही के पीछे सब चल रहे हैं। Why the high altitude the second? That means it will have lowest pressure. High altitude में lowest pressure क्यों होगा? अच्छा,
Because there
all
is
of you, बताइए बताइए।
low molecules, something like that.
low molecules.
So I
थोड़ा
don't
और
know
सोचिए।
exact meaning, sir, like answer,
अच्छा,
because I also
exact
remember from
explanation.
past.
अच्छा, okay, fine. So is there anyone who can explain it? You all can lower your hand, and the one who can explain it, just हाँ, मानसी बताइए, साथ में तो गिरा दिया हाथ।
I
Yes, मानसी।
think it's because
हाँ।
the air gets thinner as you go higher.
Now
Maybe
the
because of
level
that.
there. Why it gets thinner?
Because of the weight, it stays near the Earth's surface.
अच्छा, उस हिसाब से आप बात कर रहे हैं। Okay, fine.
Yes.
Yeah. Okay. So yeah, that can be a kind of explanation that you can have. That can be one explanation. The other thing you can see is that is sea level, whatever pressure you are feeling, that is due to the atmosphere. Is that right? Yes or no? है ना? Correct है? That is due to atmosphere.
Yes,
In
yes,
atmosphere you have gaseous particles. These gaseous particles are pulled down by Earth's gravity, है ना? And as they are pulled down by Earth's gravity, they are having a net downward force, which is why we experience one atmospheric pressure. Okay. Now, if you are at sea level, then you are experiencing this much atmosphere, right? All the air that is present here, you are experiencing all of these air, and all of these air is exerting some pressure. But if you are at high altitude, आपको आराम से दिख रहा होगा that the atmosphere that you are going to experience is way less than what you are going to experience at sea level. Yes or no? The amount of air that you are going to experience is less, ना? That pressure भी क्या हो जाएगा? Less हो जाएगा. Correct? Yes or no?
Yes.
ठीक है, so you have all these air particles. These are having a downward force on, and this is why you are experiencing. And here you have less number of particles in air. तो हमारे पास जो order होगा, the order will be something like this, that the second one is going to be least, followed by the first, that is sea level, and then followed by the third one, that is deep sea. Is that correct? Yes or no? Is that correct? Yes or no? Please tell me.
Yes, sir.
2, 1, 3.
Yes,
Okay.
sir.
Now in the second case, you are having pressure. एक में क्या है आपका? Pressure is equal to 1 atm, है ना? Second में you have pressure that is less than 1 atm, and in the third case you have pressure that is more than 1 atm. Is it right? Yes or no? Please tell me. No problem till here.
Yes, sir.
Okay. अब देखिए, दोनों में ही प्रॉब्लम है. You will not have any problem in the first case where you have normal pressure that is equal to 1 atm. But if the pressure is less than 1 atm, please listen very carefully. Don't write anything. If the pressure is less than 1 atm, then the solubility will be higher or lower. Relatively 1 atm से क्या हो जाएगा? Solubility
Lower.
कुलसुम, यूसुफ, आपको समझ में आ रहा है? Yes or no? Please tell me.
Yes, sir. I understand.
Okay. So solubility will be lower. अब जब प्रेशर 1 atm से ज्यादा है तो यहाँ पे क्या हो जाएगा? Solubility
Higher.
very good. Solubility will be higher. Now, if the solubility is lower, that means the things that should have dissolved in blood, they are also not getting dissolved. And if the solubility is higher at deep sea level, things which should not get dissolved are also getting dissolved. Yes or no? Any problem hoga na? At the end,
Yes, sir.
if you look at the greater picture, what is the problem in solubility low? That the things which should have getting dissolved, which should have been getting dissolved, they are not getting dissolved. Pressure if एक ATM से ज़्यादा है, then things which should not get dissolved, they're also getting dissolved. So we'll look at the second case first, and that will also give me the second application. Second application. So second application में क्या है? Higher altitudes में क्या होता है? In higher altitudes, please write this with me. In higher altitudes, as the pressure is low, solubility of O2 decreases. Which leads to lower concentration of oxygen in blood. If you don't have any, if you have less oxygen in the blood, then what is going to happen? Then obviously your system will not work properly, है ना? Which leads to lower concentration of blood, will cause dizziness and weakness, है ना? And if the oxygen in blood it is not reaching your brain, then you will not be able to think also properly. Okay, and weakness. The condition is known as anoxia. There is also one more name for this, that is altitude sickness. Is this clear till here? Yes or no? Please tell me. The second point.
Yes, sir.
All of you.
Yes, sir.
Atif, how are you? आपकी आवाज नहीं आ रही है आजकल.
Fine, sir.
Fine. Write this down. Okay. Krishna, Kulsum, Mansi, done?
Yes, sir.
Done, sir.
Done. All of you done now? Is there anyone who is still writing? Is there anyone who is still writing? No. Okay, fine. Now let us look at the third case. The third point in the deep sea. Now, who will go into the deep sea? Deep sea divers will go to deep sea. Okay? So don't write anything. I'm explaining now. Don't write anything. You have deep sea divers. Now these deep sea divers, they will go inside the sea. है ना? तो वहां तो ऑक्सीजन होगा नहीं. So they have to take gas cylinders. Now this gas cylinder, it will have oxygen in it for sure. But how should we keep the composition? So initially, when the manufacturer of gas cylinders, they thought that see, atmosphere is mostly composed of nitrogen and oxygen. We can say 70% is nitrogen, 30% is oxygen. And if the atmosphere is like that, and we are habituated to 70% of nitrogen and 30% of oxygen, and we are breathing in oxygen only, and we are taking in oxygen only, not the nitrogen, then we are going to keep the gas cylinders composition as 70% of N2 plus 30% of O2. Okay, they said that we will keep this as the composition of gas cylinders. But the thing is that N2 is not soluble at 1 atm. And the normal जो sea level में nitrogen, if we are at sea level, we are experiencing 1 atmospheric pressure. and at that point of time, nitrogen is not soluble at 1 atmospheric pressure. If I increase the pressure, then the nitrogen will get dissolved. So what happens? See, your first position, that the deep sea diver will always be at sea level, right? Then what he does? He dives in. Okay, don't write anything, just listen. What he does? He dives in. Okay, so he dives in, and after diving, he's at deep sea level. Okay, deep sea. And after that, what happens? He has to come back, right? So he will also come back to sea level. ना कोई जाएगा तो फिर वो वापस भी आएगा. When he comes back, then he is again at sea level. Okay. Now at sea level, the pressure is equal to 1 atm. Deep sea में क्या होता है? Pressure is greater than 1 atm. ठीक है? And at sea level, that is again 1 atm. जब sea level में है तो N2 not soluble, है ना? अब धीरे धीरे क्या हो रहा है? Pressure is increasing. As you are getting deep inside the sea, the pressure is increasing. और जब ये अंदर चला गया बिल्कुल समुद्र के, then N2 is soluble. ठीक है? Now again the pressure is decreasing. When he's coming back, sea level में वापस आ रहा तो pressure is decreasing, and again the N2 is not soluble. If you look at the blood vessels, then the blood vessel will something look like this. At sea level में तो कुछ नहीं होगा, you will just have blood and its normal components. So I'm just denoting it like this. लेकिन जब deep sea में होगा, then you will have this same component here, but this same component will be also having some nitrogen dissolved. So nitrogen को हम yellow color से दिखा दे रहे हैं. Okay, so here nitrogen that is inside the blood vessel. अब ये उतना problem की बात नहीं है, because nitrogen itself is what? It is a inert gas. It doesn't react easily. ठीक है? So it will not react with the components of the blood, but what will happen if it? अब क्या है? यहाँ पे तो soluble नहीं है, तो nitrogen को बाहर निकलना पड़ेगा, right? And if the nitrogen is going to leave, it will be leaving out with some bubbles. है ना? Bubbles का मतलब there are vacant spaces. There are vacant spaces in your bloodstream. So these are what? These are bubbles. ठीक है? Bubbles जो होंगे, bubbles क्या होंगे? Bubbles are vacant spaces. Now, when you will have bubbles here, then it will cause restriction in the blood flow. It will cause restriction in the blood flow. And again, if your blood is not flowing efficiently, all the cells will not get oxygen, because blood का main काम क्या है? It has to transport oxygen, that is O2, in all the cell, and all the cell they can now burn carbon, and they can also produce energy. ठीक है? So main work for the oxygen, work for blood is for the transportation of oxygen to each and every cell. And if it is not going to each and every cell, you will feel weakness. You will also not think clearly. So all of these things happen if you have 70% of nitrogen and 30% of O2. Problem सबको समझ में आया? What is happening? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay, fine. So what we will do? आप यहाँ से इसको लिखिएगा. ठीक है? You draw this, तो आपको याद रहेगा कि what is happening. Okay. When you are done, then you will write. When deep sea divers come back to shore, the N2 in blood escapes. The end-to-end blood escapes, forming bubbles. Forming bubbles in bloodstream. Which leads to restriction in flow. Causing weakness, etc. The condition is known as bends. Okay, the condition is known as bends. Please write this down, then we will talk about how to solve this problem. So the solution which the manufacturers they came up with was to add a inert gas, that means a gas which will not react with the particles that are present in bloodstream. We have to add one more inert gas, and it should be very less soluble, and even less soluble than N2, that even if we have very high pressure, then also it is going to be insoluble in blood. Okay, so they have to find that gas, and then they put that gas in gas cylinder with nitrogen and oxygen, both of them. Okay, so the solution that they came up with was, so you will write modern gas cylinders. Have following composition. So approximately, yeah, these are all approx values. क्योंकि decimal points में हम नहीं लिख रहे हैं. So 12% of helium. So helium add किया हमने. Then we have 56. We have lowered the percentage of nitrogen. ना nitrogen का अगर content कम रहेगा cylinder में, then also the N2 will not get dissolved, right? 32% of O2. So we have got a significantly low percentage of nitrogen if I compare with the atmosphere, that is 70%. Okay. So now YHE, helium is added as its solubility is very low. And its solubility is very low, and also and due to its small size, अच्छा ये स्मॉल साइज का क्या फंडा है? सी लेट अस सपोज कि बहुत अंदर चला गया कोई, है ना, एंड द प्रेशर इज वेरी हाई. इफ द प्रेशर इज वेरी हाई, then it is so high that helium also got dissolved in blood. ठीक है, what happened? Helium also got dissolved in blood. And when helium is getting dissolved in blood and it is having small size, तो जब वो deep sea diver ऊपर आएगा, then the bubbles will also be of small size. And if the bubbles are of small size, then it is not going to harm the person as much as if it was big. Okay, so if the bubble is big, then it is going to restrict the blood flow in a larger magnitude, but if the bubbles are small, it is not going to harm you a lot. Okay, so that is why two reasons: helium is added as its solubility is very low, and due to its small size. Is this clear? Yes or no? Please tell me. Everything about the application is clear?
Yes, sir.
Yes, sir.
Okay, fine. Just हमको एक चीज देखा था कि like I have taught you guys graph ना, graph of Henry's law कराया हमने? नहीं ना, प्लॉट नहीं कराया? नहीं कराया, ठीक. So write the next point.
Sir, can you scroll up?
Scroll up. Okay, sir. हाँ.
Okay.
Okay, so see, graph for Henry's law. So whenever you are going to make a graph, you are plotting against x and y. So आपको x और y चाहिए. That means you need a equation. So the equation for Henry's law is pressure is equal to kh. Sorry, kh into chi b. ठीक है? That is y is equal to mx. है ना? So you will make y is equal to mx type of graph. So the graph is against pressure and mole fraction, right? So you'll have pressure here, है ना? Partial pressure of the vapor phase. ठीक है? Pressure क्या है? Partial pressure of vapor phase and the mole fraction of solute in the solution. It will pass through origin, something like this. Okay, make this one better is fine. Okay. Now the slope here will be, this is the most important thing that you have to remember, that slope of this graph, it will give you the Henry's constant kh. Is this clear? Yes or no? Please tell me. Huh, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. छापिए इसको. Then we will move towards a very important concept, that is of vapor pressure. Then can I move on? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Now, all of you must have seen that if you keep water overnight or for a long time, and that water is covered, right? That water is covered. And in the morning, if you look at this, if you look at the, what are you looking at? You are looking at the lid that was covering the water. Then you will see some droplets of water on the lid. Yes or no?
Yes, sir.
Yes,
है
sir.
ना? Okay. So it means that there is two things that is always happening. We have some water molecule. It is escaping the liquid form and it is converting into water vapor, right? And similarly, there will be some water vapor which will be coming in contact with the water that is present in the container, cooling down, and then they are converting itself to, they're converting itself to what? They're converting itself to water that is liquid. Okay, so both of these things are happening constantly. Yes or no? Tell me.
Yes, sir.
When you have this condition where the water vapor is converting into liquid. So we have water, that is gas, it's getting converted to water, that is liquid, and water liquid is, it is also converting to water gas. So water gas converting to water liquid, it is condensation. Water liquid converting to gas, it is vaporization. So all of you are familiar with these words, right? Yes or no? Please tell me. Condensation and vaporization. Correct? Eh?
Yes, sir.
Okay. Now I can write this as H2O gas. Okay, I will write H2O. कंटेनर में हम लोगों ने लिक्विड लिया तो उसको लेके चलते हैं। हमने कंटेनर में लिक्विड लिया था H2O लिक्विड गेटिंग कन्वर्टेड टू H2O गैस, है ना। तो जो चीज हम लोग लेके चलते हैं दैट इज इन द लेफ्ट हैंड साइड रिप्रेजेंटिंग द रिएक्टेंट एंड इट इज गेटिंग कन्वर्टेड ड्यू टू इवेपोरेशन टू वाटर गैस। सो ये यहाँ पे गैस हो गया। नाउ दिस इज एन इक्विलिब्रियम, सो वी कैन राइट द इक्विलिब्रियम कांस्टेंट फॉर दिस, राइट। नाउ वाटर लिक्विड एंड वाटर गैस है तो क्या लिखेंगे हम? प्रेशर के टर्म्स में लिखेंगे, राइट। विल राइट इन टर्म्स ऑफ प्रेशर. So this Kp will be equal to how much? This Kp, it will be equal to, so what is H2O gas? The pressure of H2O gas. Okay, the pressure of H2O, है ना, divided by the pressure of H2O liquid, है ना. And also we can also write the concentration of H2O liquid, but you know that for pure substances the pressure or the concentration it will be equal to what? It will be equal to 1. Is that right? Yes or no? है ना. जो सॉलिड्स और लिक्विड होते हैं, प्योर सॉलिड एंड प्योर लिक्विड, देयर कंसंट्रेशन और द प्रेशर इज 1. यस और नो? इक्विलिब्रियम चैप्टर क्लास 11 याद है?
Yes, sir.
Okay, so now you will see that Kp it will be equal to the pressure that is due to the H2O in gaseous phase. इतना समझ में आया सबको? यस और नो? प्लीज टेल मी.
Yes, sir.
Yes, sir.
है ना. Now if the water that is in liquid state it is getting converted into gas, then all of this gas particles they will exert some pressure. Yes or no?
Yes, sir.
So this is vapor. ठीक है. The pressure exerted by vapor is what? Vapor pressure. All of you understood this thing? Yes or no? Please tell me.
Yes, sir.
Okay. So I'll write the heading vapor pressure. ठीक है. अब बस काम आपका ये है कि मेरे साथ आप लिखते जाइए. So whatever things I have explained, I will write them down. I will write them down. ठीक है. Number 1, we have to look at the equilibrium. We have to look at the equilibrium, that is H2O, which is in liquid state. It gets converted to H2O, that is in gas state. ठीक है. We'll also write at equilibrium. At equilibrium means, जो लोग हमसे पढ़े हैं पहले, equilibrium का मतलब होता है when nothing happens, right? Equilibrium is that when you don't see any macroscopic change. Macroscopic change का मतलब, you know that evaporation is happening. आपने एक ग्लास पानी में ऐसा रख दिया है टेबल पे, you know evaporation is happening, but you don't see considerable change in the content of water. So at equilibrium, what is happening? Rate of liquid to gas is what? Liquid to gas is evaporation. Rate of evaporation. Wait a second. Rate of evaporation will be equal to rate of condensation. है ना? Rate of evaporation is equal to rate of condensation. Now, for this we will write the equilibrium constant K. So Kp will be equal to the pressure that is due to H2O gas divided by the pressure that is due to H2O liquid, and this will be equal to what? Kp is equal to the pressure that is due to H2O gas. Okay. Now, what is vapor pressure? Vapor pressure is the, please write this, the partial pressure. The partial pressure of vapors in equilibrium with pure liquid, in equilibrium with pure liquid at a given temperature, at a given temperature. Okay, this is very important, at a given temperature. Please write these 4 points. Okay, is known as, ये तो लिखने, at a given temperature is known as vapor pressure. ठीक है, तो conceptually बहुत आसान चीज है, that whatever vapor you are having, they will be exerting some pressure. That pressure is known as vapor pressure. That pressure is known as vapor pressure. And also remember, see, vapor pressure की value जो होगी ना, the pressure of H2O, see this value, it is an equilibrium constant. ठीक है, and it is an equilibrium the constant, that is why it will only depend on temperature and the nature of gas. ठीक है, temperature and nature of gas. So Atif is done, Aisha. Okay, what about others? Is there anyone who is still writing? Is there anyone who is still writing? सबने लिख लिया? सबने लिख लिया, okay. So you know that, see, अब किस किस चीजों पे डिपेंड करेगा, अगेन डोंट राइट एनीथिंग, लेट मी जस्ट टॉक. फॉर एग्जांपल लिक्विड की अगर हम बात करें, then you have two things, sanitizer and then you have water. अभी बताइए इन दोनों में से which will evaporate more easily, अगर उसको आप खुला करके छोड़ दे दो, सैनिटाइजर और वाटर? सैनिटाइजर, है ना. यानी कि if you have sanitizer somewhere, then उसका जो, then it is going into the sanitizer particle, that means the particles of sanitizer, ethyl alcohol होता है mainly, it is getting evaporated more easily. That means उसका क्या है यहाँ पे, number of particles in the vapor phase are more. That means इसका vapor pressure ज्यादा होगा. If I compare this with water, yes or no, tell me, है ना. It will depend on what liquid we are looking at, and जो liquid होगा उसके हिसाब से क्या होगा, जो liquid होगा उसके हिसाब से the vapor pressure will also change. So we can say that the sanitizer will have a higher vapor pressure than water because it is more volatile. More volatile. More volatile का मतलब, more volatile is a substance. Volatile का मतलब anything which will give out some vapors, it is volatile. More volatile का मतलब it is giving more vapors. Next term is, now this is the nature of liquid. Next term is, let us say that you have water. ठीक है, you have water. एक water है आपका, मान लीजिए कश्मीर में, है ना. And then you have some water in Rajasthan. ठीक है, अब बताइए कहाँ पे इवेपोरेशन जल्दी हो जाएगा, कश्मीर में या राजस्थान में?
राजस्थान.
राजस्थान, है ना. Why? Because it is temperature is higher, है ना. Correct है?
Yes, sir.
Everything clear? So the factors affecting vapor pressure are only two. Please write this to me. Factors affecting vapor pressure. The first factor is nature of liquid. Nature of liquid का मतलब कि liquid कौन सा है. Okay, what is the liquid? Second is temperature. Okay, temperature, nature of liquid, and then you have temperature. These are the only two factors which is going to affect the vapor pressure, ठीक है. अच्छा, let me इसमें हम थोड़ा सा expand कर लेते हैं, ठीक है. नेचर ऑफ लिक्विड और टेम्परेचर में देखिए, नेचर ऑफ लिक्विड में क्या है. फर्स्ट पॉइंट इज, इफ द IMF का मतलब क्या होता है बताइए. व्हाट इज द मीनिंग ऑफ IMF?
Intermolecular forces.
हाँ, ठीक है, इंटरमॉलिक्यूलर फोर्सेस. इफ द इंटरमॉलिक्यूलर फोर्सेस आर स्ट्रॉन्ग, अगर इंटरमॉलिक्यूलर फोर्सेस स्ट्रॉन्ग होंगे तो बताइए व्हाट विल हैपन. Will the liquid particles, they will escape out easily? Will they escape out easily or difficult? No, they will not escape, है ना. So if the EMF is strong, the particles will not escape easily, and the vapor pressure will be लो, ठीक है। अब जब हम टेम्परेचर की बात करेंगे, सो वी ऑल नो दैट वेपर प्रेशर विल बी हाई एट हायर टेम्परेचर। सही है? नो डाउट टिल हियर, यस और नो, प्लीज टेल मी।
Yes, sir.
These are the two things: nature of liquid and the temperature. Please write this down fast. Let me know when you're done. Raise your hand na if you have ever boiled water. कुछ लोग हैं जिन्होंने पानी भी नहीं बॉईल किया है, आतिफ, हिबा, कुलसुम, यूसुफ। हाँ, अनफॉर्चुनेट, अनफॉर्चुनेट, पानी भी नहीं बॉईल किया है। ओह माय गॉड। अच्छा, फाइन, ठीक है। अच्छा, lower your hand, all of you. Now, raise your hand if you have ever read a newspaper. Oh, online नहीं, newspaper. All of you have read newspaper. Krishna, Kulsum, Mansi,
Yes, sir.
Atif. हाँ,
Yes,
newspaper वाला।
Yes, sir.
ठीक है, चलो, okay, fine. You can lower your hand. But still, I think Yusuf ने raise नहीं किया था hand. Yusuf, are you there? It seems Yusuf is है ही नहीं यहाँ पे. Okay. तो सब लोगों ने लिख लिया होगा, है ना? Now I want all of you to tell me about. Let us do a thought experiment. Thought experiment का मतलब होता है सिर्फ सोचना रहता है एक्सपेरिमेंट में, और उसी से हम लोग कंक्लूजन निकाल सकते हैं, ठीक है? All of you think that you are boiling something, ठीक है? बॉइलिंग के लिए आपको क्या चाहिए? You need a source of, you need a heat source. तो ये आपका हीट सोर्स है यहाँ पे, ठीक है? This is your heat source. एक सेकंड। है ना, ये आपका चूल्हा जल गया। आप बोलिएगा सर ब्लू फ्लेम होता है, लीजिए ब्लू फ्लेम कर दिया हमने। देन आई एम पुटिंग हियर अ यूटेंसिल, ओके, एंड वाटर रख देते हैं यहाँ पे। अच्छा, अब ये बताइए कि हाउ शुड वी बॉईल द वाटर? वी शुड कवर इट या फिर नॉट कवर इट? जल्दी बॉईल करना है तो we should cover it or not cover it? Tell me. We should cover it. All of you agree? We should cover it. Okay. So we have put a lid also. ठीक है? We have put a lid also. ठीक है? Now, ढक्कन लगा हुआ है. Can you see the water boiling? देख तो नहीं सकते ना आप? Yes. ए भाई साहब. How will you see?
No, sir.
ट्रांसपेरेंट नहीं है. लिड ट्रांसपेरेंट नहीं है ना, ओपेक है. तो देख तो नहीं सकते आप लोग. ठीक है? और आप बैठे हुए हैं यहाँ पे दूर में कहीं. ठीक है? All of you are sitting here. Now since you are sitting here, अब बताइए कैसे पता लगेगा कि वाटर बॉईल कर रहा है? कोई तरीका है? इतने दूर रह के भी आप बता सकते हैं कि वाटर बॉईल होने लगा अब या नहीं बॉईल होने लगा? यू कैन जस्ट सी दैट देयर इज अ यूटेंसिल व्हिच इज कवर्ड इन ऑन अ लिड. उसमें लिड कवर किया हुआ है और स्टोव ऑन है, उसमें पानी है, तो बॉईल तो होगा कभी ना कभी. लेकिन कब बॉयल होना स्टार्ट हो गया दूर रह के आप बता सकते हैं क्या? कैन यू टेल व्हेन इट इज गेटिंग बॉइल्ड?
No, sir.
नो, नो, किसी को नहीं लगता है?
So I think the lid will fall off.
गिर ही जाएगा मतलब, अच्छा ठीक, गिर तो नहीं जाएगा, इट विल स्टार्ट मूविंग, राइट? है
Yes.
ना? स्टार्ट मूविंग, क्यों मूव करेगा?
Steam.
So due to pressure from the from the water vapor which is being evaporated.
ठीक है, अच्छा। तो इनिशियली जो प्रेशर लग रहा है ना, इनिशियली जो प्रेशर लग रहा है किस पे? लिड पे। वो कितना प्रेशर है? एटमॉस्फेयर से कितना प्रेशर लग रहा है लिड पे डाउनवर्ड?
1 atm.
180। ठीक है, दैट मीन्स द पॉइंट, जैसे ही वो लिड ऊपर नीचे थोड़ा होने लगेगा, व्हेन इट विल like whenever it will start moving, then only the boiling will start, right? Yes or no? Correct?
Yes, sir.
That means the water vapors which are here, and when you are increasing the temperature, what is happening? The vapor pressure is increasing, vapor pressure is increasing, or vapor pressure itna ho gaya that it is equal to 1 atm, then only the boiling will start. Correct?
Yes,
Yes or
sir.
no? ठीक है, so now बॉइलिंग के लिए ये नहीं कि पानी का इवेपोरेट हो जाना या फिर व्हाट इज बॉइलिंग, है ना? व्हेन विल व्हाट डू यू डिफाइन बाय बॉइलिंग पॉइंट? द पॉइंट एट व्हिच वाटर वेपर, सॉरी, द पॉइंट एट व्हिच वाटर इट गेट्स कन्वर्टेड टू वाटर वेपर। दिस इज अ रॉन्ग स्टेटमेंट। ठीक है, तो बॉइलिंग पॉइंट का जो स्टेटमेंट है दैट इज रिलेटेड टू वेपर प्रेशर, दैट इज व्हाई इट इज वेरी इंपॉर्टेंट टू नो अबाउट वेपर प्रेशर, बॉइलिंग पॉइंट। ठीक है, व्हाट इज बॉइलिंग पॉइंट? द बॉइलिंग पॉइंट इज द टेम्परेचर एट व्हिच द टेम्परेचर at which the temperature at which vapor pressure of a liquid is equal to vapor pressure of liquid is equal to what? It is equal to the atmospheric pressure. कभी कभी इसको क्या बोलते हैं? Sometimes you call also this as external pressure. ठीक है, external pressure. So this is the definition for boiling point. This is the definition for boiling point. Okay. अच्छा, अब इसी में क्या होता है, अभी हम लोगों ने थोड़ी देर पढ़ा था कि इफ आई गो टू हायर ऑल्टीट्यूड्स देन व्हाट हैपेंस? द प्रेशर डिक्रीजेस, है ना? प्रेशर डिक्रीज हो जाता है, एंड जब प्रेशर डिक्रीज हो जाएगा तो क्या होगा? बॉइलिंग पॉइंट विल बी अचीव्ड अर्लियर। फॉर एग्जांपल 1 एटीएम से प्रेशर क्या हो गया? 0.8 एटीएम हो गया। ठीक है, 0.8 एटीएम, दैट मींस द वेपर प्रेशर, I mean the liquid, it will achieve the vapor pressure. Liquid will achieve the vapor pressure easily now in less time. Correct है? Yes or no? है ना?
Yes, sir.
है ना? Because it is the atmospheric pressure has been lowered, so it will require less amount of heat, and even the temperature will be lower at which the boiling will happen at higher altitudes. इससे क्या होता है? When you are cooking something ना, when you are cooking something, तो आप तो पानी बॉईल कर रहे हो उसमें आलू डाल के, है ना? You are boiling egg inside water, लेकिन वो एग बॉईल नहीं हो रहा, वो आलू बॉईल नहीं हो रहा। क्यों? क्योंकि वो 100 डिग्री सेल्सियस तक रीच ही नहीं कर पा रहा है ना? क्या हो रहा है आपका? 90 डिग्री सेल्सियस में ही, इन 90 डिग्री सेल्सियस ओनली यू आर रीचिंग 0.8 एटीएम। अब 0.8 एटीएम हो गया तब तो बॉईल करना स्टार्ट हो गया। अब जब बॉईल करना स्टार्ट हो जाएगा तो जब तक पानी सारा का सारा बॉईल ना हो जाए, ड्यू टू द लेटेंट हीट ना, if the water is boiling, then the temperature is not changing. When the water will be completely boiled off, then only the कंटेनर, उसका टेम्परेचर बढ़ेगा, राइट? सो 90 डिग्री का 90 डिग्री है ना? उससे ऊपर जा नहीं रहा है, तो आलू ना बन रहा है, ना ही आपका अंडा बन रहा है, कुछ नहीं हो रहा है। ओके, सो विल टॉक अबाउट दीस थिंग्स लेटर ऑन। अभी तक के लिए यहाँ पे इतना ही समझिए। एट व्हाट इज बॉइलिंग पॉइंट? बॉइलिंग पॉइंट इज द टेम्परेचर एट व्हिच vapor pressure of a liquid is equal to the atmospheric pressure. Is that clear? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay, fine. Also one more point आप लिख लीजिए, then we will start the next topic. A liquid having हाई वेपर प्रेशर, एक लिक्विड का अपने आप ही वेपर प्रेशर बहुत ज्यादा है, सो इट विल बॉयल एट लो टेम्परेचर या हाई टेम्परेचर? टेल मी, विल बॉयल एट डैश टेम्परेचर, बताइए, हाई या लो?
टेम्परेचर।
लो टेम्परेचर। क्लियर है सबको?
सर हाउ लो
Yes or no? How low temperature? वेपर प्रेशर हाई है, राइट? सो एटमॉस्फेरिक प्रेशर क्या हो जाएगा, जल्दी अचीव हो जाएगा, राइट अक्षय?
ओके सर, हाँ
है ना?
ऐसे
So at low temperature only it will start boiling. Shall we? So everything is clear, right? Till here? Yes or no?
Yes, sir.
Okay, fine. So अक्षय नहीं, अक्षय तो नहीं, हाँ अक्षय का भी कंसंट्रेशन टर्म्स छूटा है ना, तो कंसंट्रेशन टर्म्स के लिए अक्षय को बुलाना है। ओके फाइन, आई विल राइट extra class, and this is for me only, okay? So अक्षय, आपका जो टॉपिक है दैट इज कंसंट्रेशन टर्म्स, राइट?
यस
जो
सर।
आपने नहीं पढ़ा है ना, जिसका आपने क्लास नहीं किया। एंड देन वी हैव Kulsum, and who is here with us? Okay, मानसी, आपने भी कंसंट्रेशन टर्म्स नहीं किया शायद, है ना? कंसंट्रेशन से हमारे साथ नहीं किया। कुलसुम है, उसके बाद वी हैव यूसुफ, वी आल्सो हैव आयशा, है ना? आयशा राइट्स ओनली वन, आयशा। So, इन लोगों ने कंसंट्रेशन टर्म्स नहीं किया है एंड ऑल्सो सॉल्युबिलिटी। सही है? यस और नो गाइस? अब बताइए, किसी और का कुछ छूटा हुआ है अभी तक? नहीं ना? आतिफ का तो नहीं कुछ छूटा है, आयशा हो गई, अक्षय होगा, हमजा हिबा का कुछ नहीं छूटा, कृष्णा, कृष्णा कुछ आपको छूटा हुआ है?
No, sir.
नहीं, ठीक है। यूसुफ हो गए, मानसी हो गए एंड आयशा इज आल्सो हियर, ठीक है। ये मेरे लिए, आप जब कंसंट्रेशन टर्म्स कराएंगे तो अक्षय, कुलसुम, यूसुफ सबको बुलाएंगे, और फिर जब सॉल्युबिलिटी कराएंगे तो कुलसुम, यूसुफ और आयशा, सिर्फ इन तीनों को बुलाएंगे, ठीक है? चलो।